what it looks like right here, which is what actin and myosin look like when a muscle is relaxed. Okay? Now, when a muscle is relaxed, so this is going to be my step one. So I'm going to start with, here's my myosin head, 90 degrees. High energy, right? Oh, I don't have enough room. High energy right there. It's my myosin head. Here is my actin. Like this, right? There is an active site on each one of these where myosin wants to bind to. Okay. So at 90 degrees, myosin has a very high affinity for actin, which means what?
It wants to bind?
It wants to bind. Right? It has a really high affinity, but if I had something in here in the way, like that, even though it wants to bind, it can't. So it will stay like this, waiting for that thing to move out of the way. Okay? Calcium will cause that to move out of the way. And we'll get to that in a minute, how that happens. But let's assume right now we moved it out of the way. So now, this thing right here wants to bind tightly to that, doesn't it? Because we're letting them. They're, Armand, I love you. Right? I mean, nothing's in my way anymore. Does that make you uncomfortable? Okay. I don't make anybody uncomfortable. It's hypothetical. Okay.
It gets the point across.
It gets the point across, right? We got to get together now. Okay. So these. This is going to bind tightly, right? Because, like we said, myosin has a really high affinity for actin, and they bind tightly. So let's put them there bound tightly. Like that, right? 90 degrees there. Okay, so it's still at 90 degrees. High energy or low energy? High energy, right? And what is it attached to? Actin. Like that. And that's where those binding sites are. Okay. Now, I'm going to give you a name of what this is called. When myosin binds tightly to actin, we're going to call that a cross bridge. So we're going to say cross bridge formation. Okay. So we just formed a cross bridge formation. Now, interestingly enough, when myosin is bound tightly to actin in this high energy state, we said it's unstable, right? So high energy things are unstable. So it wants to and will move right now, right, at this point right here, to a low energy state. Right? So we'll say it this way. This myosin head has no choice, but it has to swivel to the low energy 45 degree state. That makes sense? Got no choice, right? Energetics says it has to be so. So let's put that on there. So there I am here now. I've now moved down to 45 degrees there.
Still looks like 90.
I was attached to, still am, attached to actin, like this, here. Okay, there. But what happened when it went to 45 degrees? Actin moved. Actin was pulled, right? We pulled on actin. And if this was attached over here to a Z disc, which they are, the Z discs are going to get closer together, right? Because this pull. You okay with that so far? This right here is called, what we just did, this is called the power stroke. The power stroke is the result of high-energy myosin binding to actin in an unstable way, and then just swiveling to a more stable form. Did that release energy? Yeah, and some of the energy was used to pull on actin, muscles contracted. Now you have to realize, this is happening how many times over and over and over and over? At least a couple Brazilians.
A day.
This is just cycling on and on and on and on and on, as long as they can bind to each other. And not only that, there's more than one of these in a muscle, right? There's Brazilians of them, right? So, even though this generated such a tiny amount of force, summed over all of the cross bridges occurring at the same time, we generate a lot of force, and we can actually move the skeleton as a result of this. Okay? You okay with that? Yes?
So you said that